The topic I'm going to cover today is SwiftUI in LineLife iOS. We will present some of the ideas that went into technology selection and implementations when we choose to adopt SwiftUI in the LineLife iOS app. I'm from the LineLife client development team, and my name is Wei Wang. I'd also want to thank my colleague Lagana Antonia for reviewing the contents of this presentation. Today, instead of digging into every detail in the LineLife app, I just want to share with you some of the stories that happened between our app and SwiftUI. They are about why and how we determined to adopt SwiftUI in the app. This presentation consisted of 4 main sections. First, I will address the question, why do we need a new UI framework in our app? Is there any challenge to keep using the current technique? Then I will cover why did we choose to adopt SwiftUI instead of any other solutions. Later, we will say how the LineLife app succeeded to migrate and start using SwiftUI to boost our development. At last, I will talk about some of our experiences for reference. If you are still wondering whether you should adopt SwiftUI in your app, or if it's better to wait for a while longer, I hope that in the end of this session, our practice and experience will help you answer that question. Okay, let's get started and see why we felt we needed a new UI framework in our app. LineLife is a streaming video service that started from 2015. Over the years, we've worked hard to keep the app code as simple and slim as possible while enriching its functionality. Nonetheless, after all these years, LineLife is now a medium-scale native iOS app. It contains about 200,000 lines of Swift code for its core logic. Similar to most apps of comparable age, LineLife uses UIKit and MVC as its architecture. The model view controller architecture, widely referred to as MVC, is widely used in iOS development. However, as is well known, if it's not used correctly and carefully, it tends to result in massive view controller implementations. Originally, the view controllers plays the simple role of gluing together the view and the model. However, it is all too easy to add more code and end up with a bloated controller. The reason for this bloat risk can be tracked down to the UI framework that Apple has provided since iOS 2, the UIKit. UIKit is basically an imperative style framework. One sets the actual view's properties through a view controller. The view controller handles users' interactions and updates the views as a sequence of comments. You can almost do whatever you want and change anything there. The flexibility very soon becomes a problem. As humans, our brains give their uncompatibility. It always has an upper limit as to what we can fully understand and control. However, in the UIKit and MVC world, one needs to remember and put almost every piece of multiple state manually. Maybe it would be fine to change something here and make it correct. But it's very often that changing something else in another place can just break the old one. Then you need to take care of both states, which increasing the product scale. One needs to handle more and more of these cases, and code complexity gets wide very quickly. It's not surprising at all that one day it goes beyond human control, and then it turns into a mental burden, and then bugs are introduced. In the LineLife app, I guess we're just here. The current technical stack is not causing a huge pain yet, but it's starting to become a problem. Thus, we really want to find a way to reduce both of the code complexity and amount of mutability in the code. We can then return to a peaceful and happy world. So this is our goal. To reduce code complexity, we want an easier mental model. If we can just describe the result we want and let the machine determine the concrete steps to achieve that target, we can get rid of the details. That is a declarative programming. To reduce the mutability of code, we want to avoid changing the states without any rules. A central control and a functional way can provide more stable state management for the code. This is functional programming. It's not a new concept at all to use declarative and functional programming to improve software development quality, especially for front-end and client applications. There are already quite a few successful examples in our industry, and it's now a proven best practice. In WWDC 2019, Apple also announced SwiftUI, their UI development solution based on declarative programming. Looking back over these years, we had a few options to use declarative programming. There were React Native, Flutter, and more. And there is also the choice of just stay in the comfortable zone of UIKit. It has indeed served us well until now, and all members are familiar with it. So, why would we make the decision to try SwiftUI, especially after 3 years since its initial release? In this year's WWDC, Apple promoted SwiftUI using this strong slogan. And what is most noticeable is that Apple starts to provide SwiftUI-only frameworks. Most of them are related to lock screen, such as WidgetKit and ActivityKit. But there are also some very useful and beautiful frameworks, like Swift Charts. Without knowledge of SwiftUI, you cannot even use them in your app. There is no doubt that there will be more in the future. Compare that with the number of the new frameworks that are UIKit only. Unfortunately, it is 0. It's a very clear signal that the trend for future iOS UI development is SwiftUI. At WWDC this year and last year, Apple held launches during the conference. In both years, SwiftUI was the most popular topic. Apple is also devoting more resources to SwiftUI now. We've submitted some UIKit and SwiftUI issues almost at the same time. Guess the result? SwiftUI issues got fixed quite quickly, whereas we are still waiting for the reported UIKit issues to get fixed. In recent years, the Swift team keeps adding new syntax like result builder and property wrappers. They are all about writing SwiftUI in a beautiful way. With all of these resources, we wanted to try SwiftUI in our app. Okay, so we made the decision to start adopting SwiftUI. Let's see how we chose to migrate from the current UIKit stack to SwiftUI. We set 3 goals for our migration progress. First and most importantly, LineLive is an existing service. There is no good reason to rewrite the already working parts with SwiftUI now. We want to find a way to implement new things using SwiftUI while leaving the existing working components alone. Second, during the migration, we want to help all team members to become familiar with SwiftUI so that we can start to work with it as soon as possible. Last but not least, we have to evaluate the cost, especially compared to UIKit. This will help us to make a final decision on whether the migration benefits outweigh the cost. With these goals in mind, we soon choose our starting point, a debug panel inside the app. This debug panel is a screen that is only used in our internal builds. It allows developers and QA members to check the internal app states and toggle some hidden options. The layout is very simple. It is composed of a list with sections. The cells are created with simple basic building blocks in SwiftUI. Since it is not used in production, we can develop it and adjust it without having to wait for a design or specification. It is an ideal playground for any developer to try how SwiftUI works. With this, we learned how to lay out everything, apply styles to the UI, and other important basic concepts in SwiftUI. We were very happy with the results. It is so easy in SwiftUI to make such a list. If we were in UIKit, it could have been quite tricky to implement the same list. After the first step, we decided to go further, to build a more complicated thing. It is again a debugging tool to log requests and application states during development. If not attached to Xcode, it was sometimes a pain to check app logs. So we built this in-app log viewer with SwiftUI. It is basically a list that shows every log entry with another settings screen to set some features. These features can help us to find the logs of interest. This involves some more concepts, such as navigation, data sharing, and basic architecture. It is more than a simple pure UI. While building this more complex example, we found that SwiftUI's built-in way of managing data might not work too well. I will talk more about it in the next section. After that, we decided to build something more practical and closer to a real app. Again, it's for internal use by developers and the QA team. In the LineLive app, we have quite a few downloadable resources. These resources are used when viewing broadcasts, and they are not downloaded until necessary. We wanted an easy way to browse them in one place, so we created this tool app, of course with SwiftUI. This app is a side project with the same refactoring using Swift concurrency in LineLive app. This gave us a chance to let SwiftUI do more and see how it actually performs on a larger scale. With this, we verified some real-world concepts, like concurrency networking, list performance, and complex app architecture. Next, we began to adopt SwiftUI for production use in LineLive. We started with some very simple things, for example, a setting form with only a toggle and a navigation link to another page. It's a simple page that can be easily rolled back if we find even a single problem. We could even apply A/B testing to show the UI by UIKit or by SwiftUI in the same binary, since the cost is pretty low. The result was fine. The related things were working well in a production build. This encouraged us a lot to proceed to the final step. Yes, finally, it was time to build the whole new feature with SwiftUI. Recently, we released a community feature, which is a pure SwiftUI implementation. This was more complex than any other previously mentioned SwiftUI cases. Although at the first glance, the layout appears to be just a vertical stack, this screen has multiple states under different conditions and even includes complex animations. We created a self-content module for this new feature. It basically only needs minimal external input, such as an ID number, and then it performs other work internally. This allowed us to build the screen without any major external dependencies and able to quickly preview the changes. Since the rest of the app is still using UIKit, we had to expose some APIs to the UIKit world. This was our first step to build something significant and completely new with SwiftUI used in production. We learned quite a few things from the experience. I will again talk about that very soon. Before continuing, let's review our migration path. Our migration path was very clear, grateful, and controlled. We used it internally before moving on to production, from very simple cases to complex ones. At each step, we could review the SwiftUI usage in our project. We kept asking ourselves these questions. Does it work as expected? Is there anything uncomfortable when using it? And finally, is it future-proof? In software development, issues do not usually rise themselves until one starts doing actual real work. This migration path gave us a chance to pick up the correct tools and verify everything before we finally adopt it for production use. So you may want to ask, how do you feel when using SwiftUI? Is it worth spending time on it? Here are some experience and ideas we want to share from our migration. We mainly had two main issues during the development. The first challenge came up when we built the log list with the widely used ObservedObject in SwiftUI. In this case, we have two screens. The main log list shows the log entries, and a setting screen allows the configuration of some features such as the log level and log tags. You can navigate to the setting page and set features there. Any features change are reflected back to the list. This is a very common pattern even in a production app. In the settings page, we use an ObservedObject to hold the feature setting state. When choosing any of the log levels, the data is updated perfectly. In the log list, we are using another ObservedObject to drive the UI. It contains all the logs as a data source for the list and also a log settings. Based on it, we can filter the desired logs. We pass this settings object to the settings view in the navigation link. So the structure is simple and clear enough. Either screen can work without any problem on their own. However, once combined, we find that the feature settings are not passed back to the list screen, and the list content won't update. What happened? The root cause lies in how ObservedObject works. Whenever a published value changes, it sends an event out, and the ObservedObject will make current view subscribe to that event and reflect the changes. When things come to this case, we have a nested ObservedObject. The log list contains the log settings. The log list view only subscribes to the changes in its direct variables. But for the nested setting object, the changes there are not passed back to the parent one. To fix this, a possible solution is not using an ObservedObject directly on the child value. Instead, make it a binding, which instead of a reference also change the value behind it. We also need to pass in the binding value when applying these changes. Now the value modifying applies directly to the root object, and the view are updated as expected. This is quite confusing when the app logic become larger. Besides this, another risk is that ObservedObject can be delivered everywhere. Any holder of the object can edit its contents. Furthermore, the state change can also happen inside the view code, which in turn causes the view to be closely coupled with the model changing logic. That would be even harder than using a view controller in UIKit. It is not easy to always remember these rules. To solve it, we really need a simpler statement management. Ideally, we just want for the data to flow clearly and smoothly through the views without any surprise. Another potential issue that we found was how to control the dependency and perform data sharing between views. Let's take a look at this example. It's a screen composed of two child views, some controls to start the dialog, and a list below to show every downloaded resources. Usually, when building a screen with SwiftUI, we start from child views. In the first step, we prefer to define child views as pure views. That is to say, the view does not hold and change its state. It just receives some data and displays it. This way, we can use Xcode previews to check the child view with only given data. These pure views are the basic components of the screen, or in other words, the parent view. When we complete the pure views, we can use them to compose the entire screen and preview everything. On the other hand, we actually need some real data to fill the child views. The most common case to get necessary data is from our remote backend through an API client. To do that, we usually call a certain method inside the parent views on a peer block to get some data. Then we can pass these necessary pieces of data down to each child view and construct the UI there. But sometimes things will be different. Consider the case that one day we want to reuse one of these child views. The backend developed a new API for that component, so we can use it on its own. So maybe we want the child view to be able to manage some data and states itself. Once a child view contains its own data management, it's not a pure view anymore. There will be other issues to consider. Among them, the most critical is how to inject dependencies. For example, to get data from the remote server, we need an API client, maybe some user credentials. Of course, we are already doing the same thing in the parent view, so we can have the parent view to pass them into child views. However, this causes a problem. Since the assumption of pure view is broken, it will become very difficult to continue using Xcode previews to develop the child view. Some of these dependencies, such as user credentials, are only valid at runtime, and the API request can be time-consuming. Writing tests for such views is very hard. This dependency model slows down our development, and we are back in a situation where we need to always build and run the app to confirm any changes. To solve this dependency issue, first we want to keep the views as small as possible. It should be an independent component so that it can be composed easily into larger ones. It is best to be a pure view. If a dependency becomes necessary, we want a more robust, compiler-safe, and efficient way to inject and manage it. Luckily, after some searches and trials, we found that the composable architecture, known as TCA, might be the good choice. It is a Redux-like architecture to build applications in a composable way. I will not cover this TCA in detail in this session, but please allow me to introduce some basic concepts here. TCA tries to separate the view and the logic into several roles. When used in SwiftUI, TCA follows the same fundamental principle. Let the state derive the UI. First, it uses a store to wrap the state and use it to drive the UI. The store plays a role of subscription of the state in the view. It wraps up SwiftUI's state management, giving an easier way to use it. When the user taps a button in the UI, it can send an action. An action is a signal that state may change. Then the last important role, the reducer, will catch it. In the reducer, the current state, the received action, as well as the dependency, work together to derive the next state. When using TCA to replace the views containing a state, we get several working components of their own. For the child view, instead of passing the dependency in an insecure way, now the TCA can deliver it with its dependency type safely. And for states in the child view, TCA's reducer provides a common pattern to pull back the data to upper levels. Furthermore, the reducer is the only place where we have a multiple state. So the compiler ensures that we cannot change the states anywhere else. It is really useful to keep the related code together in a nice way. By introducing TCA, we solved these two problems. It cleared these major obstacles and allowed us to use SwiftUI confidently in production. Let's talk back about the new community feature now. Although it looks quite simple and in this screen, in fact, it contains a lot of other types based on the data and depending up where it is displayed. Previously, we handled these types of screens with storyboard. The storyboard is good for static screens as you can quickly preview the UI if there is only a single version to create. But in this case, if we used storyboard, we would have to build and run the app again and again to preview the UI for all variations. That is not all. This screen also requires a different layout based upon orientations and change size for different screen sizes. If carefully looked at, you will find that the size and position are slightly different. This very quickly becomes a nightmare if using storyboard, but with the combination of TCA and SwiftUI's preview, we can very quickly check all them in Xcode. After implementing this feature, we looked back on the time we spent on it. Initially, we did an estimation for the task with UIKit. The result of using SwiftUI turned out to require about only half of the time. SwiftUI combined with TCA and Xcode previews dramatically boosted development. Less code, less time, and fewer bugs. life is good. So starting last year, we began to attempt a conversion of our existing technology stack in Line Life app from a pure UIKit and MVC stack to a mixed one with SwiftUI and TCA2. It is obviously not realistic nor productive to convert or rewrite the whole app with SwiftUI, but we are trying to use a new UI framework as much as possible going forward. For foreseeable future, the Line Life app will involve both UIKit and SwiftUI. However, we believe SwiftUI is definitely the correct direction for the next generation of app development on iOS. Most importantly, we have already gained some benefits from it. We're generally happy with our journey with SwiftUI thus far. Now let's come to the last question for you. Should I use SwiftUI? I would suggest evaluating your app's scale first. If your app appears to be reaching uncontrollable scale, and you are starting to feel that adding a new feature or fixing existing bugs is becoming a pain, then maybe you should consider trying SwiftUI. It gives you a brand new way to review your code design and forces you to use a better architecture to link your data and your UI. If you are going to start a brand new app, you can try to build it with SwiftUI from ground up too. Remember that the final purpose is to lower the complexity and bring the app under control. There are many more ways to accomplish the same thing, but among them, SwiftUI is the official and recommended way. I need to also point out that although SwiftUI is very easy to use, it's also very easy to use in the wrong way. In some cases, you may find that SwiftUI is not working as you expect or that it's just not that intuitive. But in our experience, this is mostly due to a lack of understanding of some of the important underlying concepts in SwiftUI. So I would suggest that you become familiar with this before embarking on your journey to fully adopt SwiftUI. First, the view lifecycle. SwiftUI is using a hidden identifier system to mark views and controls their appearing, refreshing, and releasing events. You need to keep it in mind, otherwise you would be confused when seeing some events happening repeatedly, but others not happening at all. Secondly, the layout system. You have to understand that SwiftUI is using a cooperative way for layout. The parent first provides a proposed size to its children, and the children views return their sizes based on their own logic. Indeed, you can do a trial and error to find the solution, but it is inefficient. Understanding the layout system of SwiftUI can help you create your app much faster. Lastly, you may find there are lots of deprecated methods or types in the SwiftUI framework. The SwiftUI team is continually refining the APIs, and this can break things in previous versions of the system. The situation has gotten better in recent years, and I believe SwiftUI is becoming much more stable now. I would suggest to use the latest versions whenever possible. We were watching SwiftUI's evolution for some time already. Currently, there is more and more work that can be done with SwiftUI. Based on our experience, it is capable to handle the UI development for our project and is serving us well. If you are still using UIKit and have a need to bring your app under control again, it is really worth giving it a try. However, the path you take to achieve that goal is really important. Instead of accepting it without any thinking, we think that it's best to use a clear, gradual, and controlled migration path with small incremental steps. Find the comfort zone and potential problems at each step, and at last, become familiar with the whole thing to make it best tool in your UI development toolbox. That is all for my session today. Thank you very much.
ワンさん、ありがとうございました。
Mr. Wang, thank you very much. Starting from here, we will invite questions for a plus talk in which we will deep dive into the content of the session, focusing on the points that the questionnaires themselves are interested. We hope to continue conversation while incorporating questions from the audience to the extent possible. If you have any questions, please feel free to submit them by clicking the question mark button in the lower right corner of the screen. And the questioner is Mr. Kento Yamaguchi. Mr. Yamaguchi, can you just briefly introduce yourself? Yes, this is Yamaguchi, and I am usually doing the iOS and app engineer as a developer. Hello? Okay, so without further ado, Mr. Yamaguchi, were there anything that you're concerned of? Yes, actually, I have a couple of questions, but I'd like to comment about this presentation first of all. In the Yahoo email, we are still using the UIKit, and we would like to start implementing the SwiftUI sooner or later. And as one of the reasons for the implementing this is because we get more efficient development, but we have the activity kit or SwiftChat, and they are providing this framework just for from the Apple. And in order to use this, we believe that that we can use SwiftUI, and that can be a good reason to switch to SwiftUI. So with that, I have a couple of questions about the presentation. One thing I was very concerned of was that when it's been 3 years since the SwiftUI has been released, and you gave a couple of reasons for that. Then I'd like to know what was the most major reason for you to implement SwiftUI. And of course, the development efficiency is increased, or maybe there are other reasons, or starting from 2015, we have a Live, which is a large product, and using this as SwiftUI on that is probably a major decision to make for you. But I'd like to know what was the major reason why you decided to transfer to SwiftUI.
I think in our team, the most important reason to introduce SwiftUI is our app is almost beyond our control. That is, with the states not an amount of states increasement, we have to handle more and more conflicting with UIKit and in the old way of development. With SwiftUI, it just introduced a whole new pattern of UI development to the iOS, and we can try it to simplify our state management and just let the model to drive the view in a forcible way. Before in MVC world, it's too flexible and we can change everything. But with SwiftUI, it just makes some rules for us to follow, and I guess it's the most important reason.
Okay, thank you so much for the explanation. Since we don't have enough time, so I'd like to move on to the next part. For the goal of the migration of SwiftUI, and you're going to implement a new one for the SwiftUI, and you're not going to rewrite the existing ones. And I agree with this method because the existing component can be huge, and it's going to take a long time to rewrite them if you're going to switch everything to SwiftUI. But one thing I was concerned of is that are you saying that you are not going to rewrite everything, all the existing ones, 100%? But if you are rewriting everything 100%, maybe it's going to be more simpler to write the codes. There are some advantages to that, I thought.
Our development, we just write new things with SwiftUI and keep the old things untouched. But as maybe you have already noticed in our migration path, we have a screen, a setting screen with a toggle and a navigation link. That is originally written in UIKit, but we rewrote it with SwiftUI. I guess it is not strictly 100% that we cannot use SwiftUI to rewrite something, but it really depends. If a team member want to learn SwiftUI, the easiest way or the fastest way is just rewriting some simple components. then they can get familiar with SwiftUI very soon. That is also our rules. If you want to learn SwiftUI, you can try to rewrite some simple things. There is no way or no need to forbidden that kind of job.
なるほど。じゃあ勉強のために
I understand. So partially, you have been doing the activities for your learning session in that way. Understood.